All right, y'all. So today, man, we're gonna check in and get a little update in on our little senior citizen probe. All right, Voyager 1. All right. Nah, I'm just playing, man. Let me respect my elders. Voyager been around way longer than I've been alive. So we're gonna check in and get a little update and see what's going on. This video is titled Voyager 1 just made contact with a highly advanced object in space. So maybe it sent back some interesting data. All right, we're gonna check it out. If you're new, you know what to do. Hit that subscribe button and join the family. Let's see what's going on.
Well, this is just contributes to the number of discoveries that Voyager's been making.
The universe is a vast and awe-inspiring place, and although Earth is an incredible planet, it is just a tiny speck in the grand scheme of things. With the advancement of technology, humans have been able to launch rockets and satellites into space, leading to an insatiable thirst for knowledge about the mysteries of the universe. While we have a decent understanding of how the universe works, much of our information is based on conjecture and speculation. That's why space probes like the Voyager 1 and Voyager 2 are so crucial to our comprehension of the cosmos. These probes are beaming back real-time data, shedding light on the farthest reaches of our solar system and interstellar space, which we may not be able to visit for many years to come. But what happens when this data includes a terrifying warning that changes everything we thought we knew about the universe? Join us as we delve into what Voyager has discovered so far and the unsettling message it has sent us about the future. For nearly half a century, the Voyager missions have been at the forefront of space exploration, providing invaluable insight into the mysteries of our solar system. It's hard to believe that these missions were not intended to last this long, given the wealth of information they have yielded. The story of how the Voyager program came to be is a fascinating one. It all began with a fortuitous discovery by Michael Minovich, who realized that a spacecraft could use the gravity of a planet to slingshot further into space.
So smart, man.
This led to the launch of Voyager 1 and Voyager 2 in 1977, with the aim of studying Jupiter and Saturn. What followed was nothing short of a miracle. Both Voyagers are equipped with 3.7-meter radio dishes and 16 thrusters to adjust their orientation and direct their dishes towards Earth. Their engines use hydrazine fuel, and their electronic components are powered by plutonium-fueled thermoelectric generators. Both carry 11 scientific instruments, half of which were designed to study planets and have since been turned off. The grand tour of the 4 planets has now become a remarkable achievement in human exploration. Voyager 2 successfully completed the first ever close observations of Uranus in 1986 and Neptune in 1989. While Voyager 1 overtook Voyager 2 a few months after launch, passing Jupiter in 1979 and Saturn in 1980, and has become the farthest distant artificial object from Earth. While Voyager 2 still has 5 functioning instruments, Voyager 1 has only 4, but they both remain crucial for gathering valuable data on the deep reaches of space. Today, the 2 spacecraft continue to journey beyond the Sun's influence and into interstellar space, sending back valuable data on the cosmic environment. Before delving into the messages received from Voyager 1, let's first look into some of the discoveries and things both Voyagers encountered along the way. Imagine embarking on an epic journey to explore the uncharted depths of our solar system, with 2 trusty spacecrafts as your companions. Your first mission, take a closer look at the mighty Jupiter and Saturn systems. And boy, did those probes deliver. They transmitted a plethora of never-before-seen images and gathered extensive data, completely revolutionizing our understanding of these gas giants and the iconic ringed planet. But while Voyager 1 bid adieu to our solar system and ventured into interstellar space, Voyager 2 still had some exciting pit stops in store. In 1981, a corrective maneuver was made to set Voyager 2 on a course towards Uranus, and after exceeding its originally predicted lifespan twice, the spacecraft finally arrived at the remote ice giant in January 1986. But that was just...
Doctors was like, Voyagers, you only got this amount of time to live. And Voyagers gave him the middle finger. It was like, bump that. We in control of our destiny. And they just kept going, bro. That's crazy.
Finally arrived at the remote ice giant in January 1986. But that was just the beginning. On its way to Uranus, Voyager 2 discovered 10 previously unknown moons, adding to the growing celestial family. But the ultimate destination was Neptune, where Voyager 2 captured more than 9,000 images and made an incredible discovery: 9 previously unknown moons. But that wasn't all. Triton, the largest of Neptune's moons, had some fascinating secrets to reveal. It turns out that Triton's diameter was not as previously thought, and the satellite had surprisingly few impact points on its surface. And its brown-white coloration? Geysers. These volcanic formations spew out liquid nitrogen that freezes into white nitrogen snow upon landing on the surface. With these incredible discoveries, the Voyager mission left an indelible mark on our understanding of our cosmic neighborhood. No other spacecraft has revisited Uranus and Neptune after Voyager 2's journey. However, scientists have still been able to observe and study incredible phenomena on these planets from afar. And now, get ready to be amazed as we reveal the secrets of these mysterious spectacles. Uranus. When it comes to ice giants in our solar system, the list is pretty short, with only 2 members: Uranus and Neptune. Despite the name, the majority of these planets' material is not actually frozen, but instead consists of hot, supercritical fluids made up of volatile chemical compounds like water, ammonia, and methane. It's a state of matter that combines the properties of liquids and gases. At an average solar distance of 1.8 billion miles, Uranus is the second outermost planet in our solar system, and its diameter is over 4 times that of Earth. It takes Uranus about 84 years to orbit the Sun, and during that time, it does something strange. It appears
It just feels like Earth is like the little brother, little kid brother that's always following you around. You know what I mean? You can never really shake them off. That's how I feel. Because all of these planets just swallow us up in size, man. It's crazy. We were just talking about that with Neptune.
to be lying on its side. The reason for this peculiar axis inclination is unknown, but scientists think it may have collided with a large protoplanet early on. This could explain the 27 moons orbiting Uranus, which may have formed from the debris of the collision. And if that's not enough to intrigue you, a massive white spot was discovered on Uranus's upper atmosphere about 10 years ago, thanks to the Hubble Space Telescope. It turned out to be a gigantic storm, whipping around at speeds of up to 89 miles per hour, larger than the United States. But if you think that's wild, imagine the freezing temperatures of Uranus's methane and ammonia clouds, which can drop to a chilling minus 323 degrees Fahrenheit. And don't forget, just like Saturn, Uranus has its own ring system, although it's much sparser and less abundant. Neptune. In 1846, a bluish shimmering planet was added to the star charts, and we named it Neptune. This outermost planet of our solar system is nearly 3 billion miles away from the Sun, making it quite the loner. To put that into perspective, the distance between Earth and the Sun is only about 90 million miles. Despite its distance, Neptune is similar in size to its ice giant neighbour Uranus, with a diameter of 31,000 miles. However, in terms of mass, Neptune takes the cake with a whopping 17 Earth masses compared to Uranus's 14.5 Earth masses. Neptune takes a whopping 165 years to orbit around the Sun, but it spins quite quickly on its axis, taking only 16 hours to complete one rotation. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it captured some wild weather phenomena, such as bright bands of clouds in the atmosphere and storms that reached top speeds of up to 1,305 miles per hour, the fastest winds observed on any celestial body. Experts believe that the lack of solar energy reaching Neptune allows these storms to whip up to such incredible speeds, but there is a chance they may disappear into thin air one day. During the Voyager 2 mission, scientists discovered the great...
Y'all heard that? In hopes of happening or disappearing one day. We don't know what day, just one day. That's crazy. That's insane.
...into thin air one day. During the Voyager 2 mission, scientists discovered the Great Dark Spot, a massive formation as large as Eurasia that was believed to be a hole in the planet's visible cloud cover. However, when scientists attempted to find the spot again a few years later, it was nowhere to be found. Some theories suggest that heat from Neptune's core caused turbulence in the atmosphere and tore the structure apart. Speaking of Neptune's core, Despite the volatile nature of this planet, scientists believe it has a massive heart. The core is estimated to be 1 to 1.5 Earth masses and composed of metal and rock, with temperatures likely reaching nearly 13,000 degrees Fahrenheit and pressures estimated at several million bar. The magnetic fields of Uranus and Neptune have been a source of wonder for scientists for a long time. These invisible forces have a peculiar characteristic. They are tilted toward the rotation axis and deviate significantly from the planet's physical center. No one has yet unraveled the mystery behind these curious alignments. One thing that is certain is that Neptune's magnetic field is 27 times stronger than Earth's. On the other hand, Uranus's magnetic field is surprisingly weaker than our home planets. Experts believe that the magnetic fields of these gas giants are generated by movements in comparatively small depth, possibly caused by ionized water. But that's not the only secret that lies within these planets. It is widely believed that Uranus and Neptune have massive cores surrounded by dense layers consisting of hydrocarbons, ammonia, and water. Scientists have been intrigued by the incredible processes that might be happening under the immense pressures at the center of these planets. One fascinating theory suggests that diamonds are raining inside Uranus and Neptune. This idea, which was once merely a thought experiment, was actually proven by a group of researchers a few years ago. The team used polystyrene, a plastic made up of hydrogen and carbon atoms, to recreate the extreme pressure conditions inside the ice giants. They sent 2 shock waves through the substance to see whether the hydrocarbon compounds would split under such pressure. The experiment generated a pressure of 1.5 million bar and raised the thermometer to a scorching 9,000 degrees Fahrenheit. The result was an astonishing shower of glittering diamonds, as nearly all the carbon atoms joined together to form tiny diamond structures. The diamonds that form in Uranus and Neptune would be much larger than those simulated in the laboratory. After they are created, these cosmic gems sink gradually towards the planet's core over a period of thousands of years. The thought of diamond rain on other planets is truly mind-boggling and adds to the intrigue and fascination of these mysterious gas giants.
I just don't think it's gonna be what we're thinking, though. You know what I mean? You may spend your whole life thinking, oh man, I just need to get there. You finally get there, it could be dangerous, man. One diamond fall and you're over with. It could be something like that. I don't know. It just sounds too good to be true. So usually when it's that, it usually is.
Over the past decade, the 2 probes have ventured into a vast and mysterious region known as the interstellar medium, the space between stars filled with sparse material, and they're still uncovering new discoveries. One of the most surprising finds is the strength and direction of the interstellar magnetic field, which has sparked lively debates among experts about the shape and activity of the Sun's magnetic domain, the heliosphere. Previously thought to be shaped like a comet, the heliosphere may actually be more spherical. And what happens to the heliosphere when sunspots appear and disappear? The spacecraft has provided some intriguing clues. When the solar wind, a flow of charged particles emanating from the sun, comes to a halt, it marks the beginning of the interstellar medium. This ionized gas or plasma is like a rock in a river, pushing against the cooler, denser plasma flowing around it. The sun-carved cavity that forms is called the heliosphere, with its edge called the heliopause, similar to how the top of Earth's troposphere is called the tropopause. Don Gurnett, a University of Iowa researcher who worked on the Voyager mission, says that when the spacecraft launched, they had no idea how far the heliopause was. Some speculated it could be as close as Jupiter, which is only 5 times further from the Sun than Earth. But as Voyager ventured further, estimates of the heliopause's distance increased, ruling out Jupiter, Saturn, Uranus, and Neptune. No one knew when or where the spacecraft would enter interstellar space. According to Don Gurnett, shortly after Voyager passed by Neptune, it detected signs of the heliopause in the distance. The spacecraft picked up strong radio waves between 2 and 3 kHz in July of 1992. Which were later attributed to 6 significant flares on the Sun that occurred over a year prior. The researchers found that the plasma from the flares eventually made its way to the heliopause, where it caused electrons to oscillate and release radio waves. The frequency of these radio waves implied a density matching that expected for the interstellar medium, revealing that the local interstellar medium is far denser than the outer heliopause. Despite appearing like a pure vacuum on Earth, it is actually quite tenuous. By calculating the speed of outbound solar material and the time it took to hit the boundary, the distance of the heliopause from the Sun was revealed to be between 116 and 177 astronomical units, providing a fascinating insight into our solar system's outer boundaries. When Gurnett claimed that Voyager had detected radio waves at the heliopause, he was met with skepticism from many scholars. Not only were these radio waves unprecedented, but Gurnett's interpretation of them also suggested that the heliopause was located at a significant distance from the Sun. To put this into perspective, the distance between the Sun and Neptune is just 30 astronomical units, while the heliopause seems to be much farther away. Despite these doubts, Voyager 1 successfully crossed the heliopause at a distance of 121.6 astronomical units, consistent with Gurnett's prediction. However, due to the controversy surrounding the claim, NASA decided to delay the announcement of the accomplishment for over a year. Although Voyager 1 did observe some indications that it had left the heliosphere, such as a decrease in high-energy particles from the Sun and an increase in cosmic rays from beyond the solar system, many researchers were still not convinced. One issue was that Voyager's plasma instrument had stopped functioning, making it impossible to measure the sudden increase in particle density that occurs when leaving the heliosphere. Additionally, it was expected that the magnetic field would point in a different direction beyond the heliosphere, but this did not happen. Even today, scientists are still scratching their heads trying to explain why the magnetic field outside the heliosphere aligns with the magnetic field inside. It's a mystery that has yet to be solved. However, Voyager's incredible journey was partially made possible by the Sun's wild outbursts. In 2012, a series of massive solar storms shook up the plasma that Voyager 1 was traveling through. As a result, electrons in the plasma began to dance and emit radio waves that Voyager was able to pick up. The frequency of these waves told a fascinating tale. Voyager had entered a denser region of space, and it was about to experience some mind-boggling surprises. November 5, 2018 marked another historic day for Voyager 2, as it also crossed the heliopause. But this time it didn't raise any concerns. The spacecraft's plasma instrument was fully functional, and it recorded a significant spike in particle density caused by the collision of protons, electrons, and other charged particles. Voyager 2 also noted a temperature range of 30,000 to 50,000 Kelvin, which was much higher than the temperature of the nearby interstellar medium. The plasma's compression when it entered the heliosphere was most likely responsible for this. Just like Voyager 1, Voyager 2 observed the disappearance of solar wind and an increase in cosmic rays from beyond our solar system. But again, the magnetic field remained unchanged, indicating that the previous result was not a fluke. Stamatios Tom Krimidis of Johns Hopkins University was amazed that both spacecraft crossed at almost the same distance, despite the solar cycle being in a different state in 2018 than it was in 2012. The sunspots wax and wane during an 11-year period, resulting in the strengthening and weakening of the solar wind, which pushes harder and then less on the heliopause, albeit with a temporal delay of roughly 2.5 years.
And see, this is why I say, like, when it comes to the Voyagers, bro, and I know I was joking about them in the beginning, but they truly have exceeded our expectation as far as things that they've done. So if we design more space probes, which we are, telescopes that are coming out in the near future that they've talked about, we can only pray they are half as good as the Voyagers and last half as long as they have. You know what I'm saying? Just the amount of things they've done and exceedingly done at a high level, giving us data, you know what I mean? Breaking down barriers, providing us with groundbreaking information and data and pictures, and it's just insane to hear it. So when they take us through an entire timeline like this, man, it's just, I can't help but love to hear it over and over again because it's just super, super fascinating. You know what I'm saying? Now, the ones that are coming out in the future, we'll be able to follow along a lot more. These came out, like I said in the beginning, way before I was born. So I wasn't on that. And then going through school and high school, I wasn't paying attention to that. So I missed all of that type of stuff. But you can best believe I'm paying attention now and to stuff like the James Webb and different ones that are coming out. getting information from Hubble and different ones that are out there already. Oh, we paying attention.
Heliopause, albeit with a temporal delay of roughly 2.5 years. Therefore, the heliosphere will expand and contract. Since the pressure from the solar wind was lower in 2012 than it was in 2018, the heliosphere should have been much smaller during Voyager 1's passage than it was during Voyager 2's. However, the roughly similar distances suggest that the heliopause is more resilient than previously thought. Even with the exact form of the heliosphere remaining a mystery, Voyager 1 and Voyager 2 continue to sail away from it. By the end of this year, Voyager 1 will be 155 astronomical units from the Sun, and signals from the spacecraft will take more than 22 hours to reach us since they move at the speed of light. Voyager 2 will be 129 astronomical units away, and is scheduled to pass the silent Pioneer 10 in late 2023 to become the second furthest spacecraft of all time. These two spacecrafts are zooming away in opposite directions, and they are now further apart from each other than either is from the Earth. Furthermore, in the middle of May of last year, the Voyager 1 onboard system, known as the Attitude Articulation and Control System, or AACS, which is responsible for keeping the spacecraft's high-gain antenna pointed at Earth, began beaming home confusing jumbles of data rather than the usual reports about the spacecraft's health and status.
I think I remember hearing about that. Wasn't that like a battery issue or something that happened to it? I think it was. I can't remember. I think we remember talking about this though.
From our vantage point, it appeared that the spacecraft had developed a condition comparable to electronic aphasia, which impairs one's ability to speak fluently. It's possible that the data was generated at random, or that it doesn't represent any likely state at all. NASA explained in a statement at the time that the AACS could be in. Even more baffling for the engineers was the fact that despite the unusual status reports from the spacecraft, Voyager 1 appeared to be in good shape. The radio signal from the ship is still strong and steady, indicating that the antenna is still pointing at Earth and is not in the configuration that the AACS declared to NASA. Similarly, despite the fact that the AACS was experiencing the same weirdness, the science systems on Voyager 1 continued to gather and transmit data as usual. Furthermore, whatever went wrong with the AACS did not activate a fault prevention system, which is meant to put the spacecraft into safe mode whenever a glitch occurs. Thankfully, NASA experts were able to identify the issue and create a solution. It was revealed that the AACS had begun transmitting telemetry data via an onboard computer that had stopped working many years before. All NASA engineers had to do was instruct the AACS to use the correct computer to relay its data home because the dead computer corrupted all the outgoing data. The next step will be to figure out what prompted the AACS to swap systems in the first place. The system most likely received an incorrect command from another onboard computer, according to NASA. While they maintain it is not a serious concern for Voyager 1's safety at the moment, the fundamental cause must be identified and corrected to avoid future anomalies. In the vast expanse of interstellar space, Voyager 1 has been a true pioneer, journeying beyond the protective shield of our Sun's magnetic field for over a decade. It's a hostile environment out there, with high-energy particles and cosmic radiation bombarding the craft from all directions. But even in the face of these challenges, Voyager 1 has continued to push forward, delivering valuable data and insights about the mysteries of deep space. As Susan Dodd, the project manager for Voyager 1 and 2, put it, strange occurrences like the recent AACS malfunction are just par for the course in this groundbreaking mission. After 45 years of exploration, the Voyagers remain a testament to the incredible achievements of human ingenuity and determination. Let's hear your thoughts about the Voyager mission in the comments section below.
Being that out there 40-something years and you're just now having some issues with it, I'd say that's pretty warranted at this point. You know what I'm saying? That's expected. We can be okay with that and deal with that and try to troubleshoot and fix it. Like I said, I could have swore I thought they said at one time it was a battery issue, but it could have just been a different issue with the computer system that they were talking about just then. But I thought it was battery. But anyway, that's neither here nor there. But anyway, y'all get at me in the comment section, man, and let me know what you thought about this video, man. The Voyager 1's extremely, extremely intriguing, man. And the things that they've been able to do, It's fascinating, mind-blowing, all of that type of stuff. You know what I mean? But y'all get at me, let me know what you thought of this video, and stick around and stay tuned. Till next one, I'm gone. Peace.